Today we're going to work on solving rational equations. Those are basically equations with rational expressions, such as this, where we have fractions within it, rational algebraic fractions. So in this situation, we have denominators of x minus 3, and technically the denominator over here is just 1, so I can kind of think of this as over 1. And then I look at the denominators, and in combining fractions together with subtraction or addition, we need to find the common denominator. Now this is pretty simple because there's only one denominator, x minus 3. So what I basically think of is I'm going to multiply this fraction by x minus 3 over x minus 3. And then what this becomes here is the top of this fraction becomes x squared minus 3x over x minus 3 minus 5 over x minus 3 equals x over x minus 3. Now, what works is since all three denominators are the same, each denominator is the same, that means the numerators must match up. The equation with only the numerators will result. So basically what I'm going to do is I essentially eliminate the denominator and just write x squared minus 3x minus 5 equals x. And I solve this. I've taken a very complicated problem, turned it into a somewhat reasonable problem. It's still a quadratic equation. We have to work on solving that. So for that one, we're going to subtract x from both sides. And I got x squared minus 4x minus 5 equals 0. And to solve that, I'm going to factor that. So quadratics, if possible, we like to factor them and set them equal to 0. So that's going to be x minus 5 times x plus 1 equals 0. If I did the FOIL, x squared plus 1x minus 5x. And this all works out. So now I have two things multiplied to equal 0. So either x minus 5 equals 0, in which case x equals 5, or x plus 1 equals 0, in which case x equals negative 1. So there are two solutions to this one, 5 and negative 1. So that would be the answer to this. Now we need to also, just to be on the safe side, we want to check to make sure neither of our solutions makes the denominator 0, and that's the case here. So this is perfect for this one. Sometimes the problems get a little more complicated here where the denominators are a little mixed up. Well, this one looks like it's going to be an issue because of this 4 minus x being different than x minus 4. What I'm going to do is I'm going to rewrite this as x over x plus 4. And what I'm going to do is switch the order of these two things here, and I'm going to have that to be 1 over x minus 4. But to do that, I'm basically factoring out a negative. And that changes this negative sign to a positive. And I have 7 over x minus 4 here. And now I go through my same procedure as far as multiplying things out. So I'm looking at common denominator, and I'm saying this x plus 4 is one number, x minus 4 is a different number, and x minus 4 is here as well. So I look at this and I ask myself, what's missing in this denominator that this denominator or this one has, and that's an x minus 4. We have to remember that x minus 4 and x plus 4 stand for one number by itself, not two separate numbers, but one number, x plus 4, and one number, x minus 4. So I need to have an x minus 4 here on the bottom. So now my denominator is going to be x minus 4 times x plus 4. This one needs an x plus 4, so I'm going to say x plus 4 and x plus 4. And remember, that's going to be with that. I guess I should put parentheses there. And this one here also needs an x plus 4. So this is kind of what I have right now. Now all the denominators are the same, so I can just write the equation using only the numerators. So this becomes x squared minus 4x plus, now I distribute that, that's just going to be x plus 4 equals 7x plus 28. And the denominators are all the same, so I don't have to worry about them. So that becomes x squared minus 3x plus 4 equals 7x plus 28. Let's combine. I'm going to get this negative 7x, get rid of that. So I want the right side, it's a quadratic, so I want to set one side equal to 0. So minus 7x and at the same time minus 28. So I'm going to say minus 7x minus 28. So that becomes x squared minus 10x. And then 4 minus 28 is negative 24. Equals, these cancel out entirely, equals 0. Now I'm going to factor that one. I can factor the bottom. I can the quadratic. This should be x squared here, by the way. Let me go back and fix that. That's x squared. So this would be x and x to give me x squared. Now I'm looking for numbers that multiply to 24 and subtract to 10. Well, I first thought of 6 and 4, but they add to 10, not subtract. So I'm going to look for numbers that subtract to 10, and that's going to be 12 and 2. And the bigger number is going to get this sign right here. So that's a minus and a plus. So now I have two things multiplied to equal 0. X minus 12 equals 0. X plus 2 equals 0. So add 12 to both sides, and I have x equals 12. Subtract 2 from both sides, and I have x equals negative 2. So those are my two solutions. Make sure neither of them makes the denominator 0, and neither of them does. So it looks like this, 12 and negative 2, two solutions. Okay, the last one. Similar, we're going to factor the bottom here. So the bottom would factor to be x plus 4, x plus 9. So now I look at the first fraction. I say, what's missing here? Well, it doesn't have any denominator. So I'm going to basically have to do x plus 4, x plus 9 over x plus 4, x plus 9. And now that's that denominator. This fraction has a denominator of x plus 9. I need to have an x plus 4 here. And this one doesn't need anything. It's all set. The denominator is fine. So now I have this right here. So I'm going to multiply that out, and that became x squared plus 13x plus 36. That's what this part here equals, times 1, plus distribute 3x plus 12 equals 2x plus 3. Again, this is a quadratic equation. I want to set it equal to 0. Well, let's simplify a little better. X squared 13 plus 3, that makes 16. X squared plus 16x. 36 plus 12 is 48. Equals 2x plus 3. And now I want to do something with this 2x plus 3. I want to get rid of that. So I'm going to subtract 2x and subtract 3. So I'm going to subtract 2x and I'm going to subtract 3. And I just put them here to line them up with the appropriate terms. So I have x squared plus 14x plus 45 equals 0. And now we need to factor that. We can factor that to be x and x, and then multiply to 45 and add to 14. That's going to be 9 times 5. And they're both the same sign and both pluses. So I have x plus 9 equals 0, in which case x equals negative 9. And x plus 5 equals 0, in which case, that's a 0 here, x equals negative 5. So my solution then would be negative 9 and negative 5. Again, before I go on to finish, actually that was not going to be my solution, because I look at negative 9 and I say, wait a minute, if I substituted in negative 9 into this equation right here, I'm going to have a negative 9 plus 9 on the bottom, which is 0. So this term here is not a solution. It's called, that's an extraneous solution. An extraneous solution is a solution that works in the modified problem, here -5, -9, but does not work in the original problem. So -5 is my only solution to this one. Okay, hopefully that helps. There's 8 problems on Delta Math for homework, so make sure you get that done. Okay, I'll see you Monday.